Welcome to Arsenal, where the weapons and war machines of military history come to life. Today, we explore the Zumwalt-class destroyers in the modern surface fleet, and the crews and opponents who gave them their reputation. If you enjoy learning how technology, tactics, and human decisions come together in combat, you can find more articles, podcasts, and resources at trackpads.com. In the gray light of a Pacific morning, a Zumwalt-class destroyer does not look like the destroyers that came before it. The familiar outline is gone. There are no stepped decks, no forest of exposed antennas, and no traditional silhouette crowded with the visual language of 20th century naval power. Instead, the ship rises from the water like a dark wedge. Its tumble-hull hull slopes inward as it climbs, and its angular deckhouse is shaped to scatter radar energy. From a distance, it seems less like a conventional warship than a moving shadow. Arsenal is the Friday feature of Dispatch, U.S. Military History magazine.
Inside the ship, the pressure is different from the battleship gun lines and destroyer screens of earlier wars, but it is still pressure. Sailors manage combat systems, propulsion loads, sensors, communications, and weapons from spaces built around automation and integrated control. They are operating inside a ship designed around networks, power, stealth, and long-range effect. The enemy may be a missile battery ashore, a distant surface combatant, an aircraft searching for a targeting track, or a command network trying to find the ship before the ship can strike first.
That is the Zumwalt-class story in miniature. It is not only a story about a destroyer. It is a story about what the United States Navy thought the future fight might demand, and what happens when a Navy tries to build that future into steel.
The Zumwalt class grew out of a difficult question after the Cold War. For decades, American surface combatants had escorted carrier groups, defended against aircraft and missiles, hunted submarines, and prepared to fight Soviet warships in the open ocean. The Navy already had a powerful answer for much of that mission set, the Arleigh-Burke-class destroyer, a capable and heavily armed ship built around the Aegis combat system. But the post-Cold War Navy also faced missions closer to shore. Land attack, naval gunfire support, stealth, and survivability in crowded littoral waters seemed increasingly important. The Navy wanted a surface combatant that could approach defended coasts, reduce its radar signature, support forces ashore, and deliver precision fire without relying entirely on aircraft or submarines. It also wanted room for future electrical power demands, because sensors, weapons, and shipboard systems were becoming more energy-hungry with every generation. Existing destroyers could perform many missions well, but they were not designed around this combination of low observability, high electrical generation, automated operations, and land attack firepower. The answer became a radical new destroyer, larger than many cruisers, shaped for stealth, powered by an integrated electric system, and originally centered on advanced guns intended to strike targets far inland. The result would be one of the boldest and most debated naval design experiments of the modern era. The Zumwalt class did not begin as one more destroyer with newer electronics. It began as part of a larger effort to rethink what the surface fleet should be in the 21st century. The Navy wanted a ship that combined land attack, survivability, reduced radar visibility, advanced sensors, and electrical power margins older mechanical arrangements could not easily provide. The class was trying to leave room for the future before the future had fully arrived. That ambition shaped the ship's appearance. The tumble-home hull, with sides sloping inward above the waterline, was chosen partly to reduce radar signature. The large angular deckhouse served the same purpose. The overall form was meant to make a vessel more than 600 feet long appear much smaller to radar than its true size. The ship did not look strange by accident. Its shape was the visible result of a design philosophy that accepted an unusual appearance in exchange for a lower profile in enemy sensors and targeting systems.
The class also embraced integrated electric propulsion. Instead of using traditional mechanical drive systems, the ship's gas turbines generate electricity that can be distributed to propulsion and ship systems. This promised flexibility. Power could be routed where needed, and future energy-intensive weapons or sensors could be easier to support. But the same ambition made the ship complex, expensive, and difficult to bring from concept to operational reality.
At a glance, the Zumwalt-class is a United States Navy guided missile destroyer built for the modern era, though its size is closer to that of a cruiser than many earlier destroyers. It carries a relatively small crew because automation was central to the design. Its original concept centered on stealth, land attack, advanced guns, missiles, powerful sensors, and high electrical generation. 3 ships were ultimately built: Zumwalt, Michael Monsoor, and Lyndon B. Johnson. The production story became inseparable from cost and changing requirements. The Navy first imagined a much larger class, but as expenses rose and missions shifted, the number of ships fell dramatically. The advanced gun system became the clearest example of the problem. The guns were designed to fire long-range precision projectiles in support of forces ashore, but the ammunition became too costly and was not fielded as planned. A destroyer built around revolutionary naval gunfire support entered service without the practical ammunition that had justified much of that role. Walking around a Zumwalt-class destroyer begins with its shape. The bow, hull sides, and deckhouse are all part of an attempt to reduce radar reflection. The usual clutter of exposed masts, antennas, ladders, and deck fittings is minimized or hidden. The ship was built to be seen late, understood slowly, and targeted with difficulty. That choice also made it controversial, especially among observers who questioned how the tumble-home hull would behave in heavy seas or battle damage conditions. The design represented the broader theme of the program: unusual risk in pursuit of a major leap forward. Inside, automation changes the human experience. A Zumwalt-class destroyer is enormous, yet it was designed to operate with fewer sailors than older ships of comparable size. That means more monitoring, more centralized control, and more reliance on integrated systems. Sailors live and work inside a ship built around networks, consoles, automated damage control aids, electric power management, and tightly integrated combat functions. Operators gather sensor data, manage contacts, track threats, coordinate weapons, and maintain communications across the force. Engineers monitor the electrical plant and propulsion loads because power generation is one of the class's core features. Damage control teams still matter. No amount of automation removes the need for sailors to fight flooding, fire, smoke, and battle damage. The ship may be advanced, but survival at sea still depends on trained people making fast decisions under pressure. Technology can help, but sailors still have to keep the ship alive. The original weapons fit reflected the land attack mission. 2 advanced gun systems were mounted forward, intended to fire precision rounds at long range and provide naval gunfire support farther and more accurately than traditional naval guns. When the ammunition problem undermined that plan, the guns remained as physical reminders of a mission that changed before the ship fully matured.
Missiles gave the Zumwalt class another layer of striking power. Its vertical launch cells were arranged differently from the dense central missile farms on many destroyers. The peripheral launch system placed missile cells around the edges of the ship, spreading risk and reducing the danger of a catastrophic magazine hit. These cells could support a mix of weapons depending on mission needs, including missiles for land attack, air defense, and anti-surface warfare.
Sensors and combat systems were central to the design as well. The ship was built to detect, classify, and engage threats while managing its own signature. The idea was not simply to hide, it was to control the terms of detection and engagement. In a missile-aged fight, the first ship clearly located and accurately targeted may be the first ship in real danger. Zumwalt stealth is not a magic shield. It is a way to make the enemy's search, identification, targeting, and engagement problem harder. Habitability was different too. A smaller crew on a large hull can mean more space per sailor, but it also means each sailor carries more responsibility. Automation does not eliminate work, it changes the kind of work and concentrates it in different places. For the people aboard, the ship's advanced design means serving inside a vessel that is both powerful and experimental. The Zumwalt story then moves from design promise into operational reality. This class did not receive its baptism of fire in the traditional sense, with destroyers charging into gun smoke or trading salvos with enemy cruisers. Its first test was quieter and more complicated. It had to prove whether a revolutionary surface combatant could become a working warship after years of debate, redesign, cost pressure, and shifting missions. The class entered service as the Navy prepared for a different kind of fight. Long-range missile warfare mattered. Contested coastlines mattered. Electronic detection, fleet networking, and great power competition across the Pacific mattered. The Zumwalt-class arrived in a world where being found could be as dangerous as being hit. The original combat vision placed the ship near the edge of dangerous waters, using stealth shaping to reduce early detection, and then supporting troops ashore with long-range precision gunfire. Since the age of battleships and cruisers, ground forces had wanted naval guns that could reach inland, answer quickly, and deliver heavy fire without waiting for aircraft. The Zumwalt-class was meant to revive that role with modern precision. But the long-range land attack projectile, the specialized round intended for the advanced gun system, became too expensive to field as planned. That left the destroyer with 2 large guns, but without the practical ammunition needed to perform the role around which much of the original design had been built. The problem forced the Navy to rethink what the Zumwalt-class would actually do. The answer increasingly shifted toward missiles, sensors, and future weapons. The large hull, electrical power, stealth features, and internal architecture still gave the class value, but the mission emphasis moved away from naval gunfire support and toward high-end surface warfare. In that role, a Zumwalt-class ship could operate as a hard-to-detect missile combatant, carrying weapons for land attack and ends while complicating an enemy's ability to find, track, and engage it. This made the class less a failed battleship substitute than a warship caught between 2 futures. One future imagined precision naval guns supporting troops ashore. The other imagined distributed fleets, long-range missiles, contested sensors, and surface ships hunting or striking from far beyond the horizon. The class was born for the first mission, but increasingly adapted toward the second. For commanders and crews, that meant the ship's strengths had to be understood differently. Its value was not simply measured by the guns on the bow. It lay in stealth, power generation, command and control potential, missile capacity, survivability concepts, and the ability to host future systems. The early battle for the Zumwalt-class was fought against cost, technology, changing doctrine, and the challenge of turning ambition into a useful operational tool. The greatest strength of the Zumwalt-class is its ambition. It pushed surface combatant design in directions the Navy had long discussed, but rarely pursued so completely. Its radar-reducing shape, integrated electric propulsion, peripheral missile cells, automation, and large internal volume all pointed towards a warship built for sensors, networks, missiles, and energy-intensive systems. It was not conservative, and that is why it remains important. The class also showed that warship design is always a set of trade-offs. Reduced radar signature required an unusual hull and superstructure. Automation reduced crew size, but increased dependence on complex systems and placed broader responsibility on each sailor. Integrated electric propulsion promised flexibility, but introduced engineering and integration challenges. The advanced gun system promised a new form of naval fire support, but that promise depended on ammunition that had to remain affordable and available.
For crews, the ship offered modern spaces, advanced control systems, and the experience of serving aboard something genuinely new. But novelty brings strain. A small crew on a very large ship means fewer people to absorb maintenance burdens, damage control emergencies, watch standing demands, and the daily friction of sea service. Automation can help sailors see and act faster, but it cannot replace human judgment when systems fail or conditions become chaotic. At sea, technology extends the crew. It does not erase the crew.
For enemies, the class presents a different problem than a traditional destroyer. Its shape makes detection and targeting harder. Its missiles can threaten targets at long range. Its size and electrical capacity suggest room for future weapons and sensors. But opponents would also study its limits: small numbers, distinctive logistics, and the operational challenge of having only 3 ships in the class. A ship can be technically remarkable and still limited by how many hulls the fleet can actually put to sea.
Compared with the Arleigh-Burke class, Zumwalt is larger, more experimental, and more focused on signature reduction and future power margins. The Burke is more numerous, proven, and deeply integrated into the fleet's air defense architecture. Zumwalt is not simply better or worse. It represents a different answer to a different question. How far should a Navy push revolutionary design when proven ships are still doing essential work?
The Zumwalt class never became the large fleet once imagined. Its evolution came through mission changes and reinterpretation. A large class can reshape fleet doctrine by numbers alone. A 3-ship class becomes a specialized tool, a testbed, and a symbol of innovation and caution. The ships still matter, but they matter differently than planners first expected. The 3 ships are Zumwalt, Michael Monsoor, and Lyndon B. Johnson. The 3rd ship incorporated some changes from the earlier pair, including differences in deckhouse construction. Across the class, however, the larger story remained consistent. These were stealthy, electrically powered destroyers whose original gun-centered mission gave way to a broader role in advanced surface warfare. The most important evolution has been the move away from the advanced gun system as the central reason for the ship's existence. With the specialized ammunition unavailable, attention shifted toward missile integration and the possibility of carrying new long-range strike weapons. In that sense, the class became less about replacing old naval gunfire and more about exploring what a large, low-observable surface combatant might contribute in a missile-dominated fight. The Zumwalt class also influenced thinking beyond its own hulls. Its electric drive architecture, automation lessons, signature control measures, and struggles with cost all became part of the Navy's learning process. Future ships may not look exactly like Zumwalt, but they will inherit questions the class forced into the open. How much stealth does a surface ship need? How much electrical power will future weapons require? How much automation is wise? How much technical risk should a Navy accept in a single leap? The legacy of the Zumwalt class is still being written. It is not a museum artifact from a closed chapter. It belongs to the modern fleet, where its purpose continues to evolve. It is at once an operational warship, a technological experiment, a cautionary acquisition story, and a glimpse of what future surface combatants may need to become. Its influence is not measured only by the number of ships built. 3 hulls cannot replace a destroyer fleet, but they can teach hard lessons. The class showed the promise of integrated electric power, the appeal of low observable shaping, and the value of internal margins for future weapons. It also showed the danger of building a ship around a weapon and ammunition combination that might not survive cost reality. In that sense, Zumwalt is both a warning and a laboratory. The Zumwalt-class Destroyer remains one of the most striking warship designs ever placed in United States Navy service. It did not become the large class once imagined, and it did not fulfill its original gunfire-support concept in the way planners expected. But it forced important questions into steel: how a ship hides, how it powers itself, how it fights at range, and how sailors adapt when the future arrives in unfinished form.